March 11th, 2011. Japan experienced a turn of events that led to the largest nuclear meltdown the world has seen since Chernobyl. This event was a major turning point in my life and one of the main reasons why I wanted to become a nuclear engineer. Throughout this speech, I will be talking about nuclear fission, what it is, the waste that leaves over, and the dangers that it poses. But due to the lack of time that I have, I will not be going as in-depth into the process as I could, but I'll try and be as informative as possible. Now, nuclear fission is the only form of nuclear energy that the world implements today, and according to the EIA, the Energy Information Association of America, the United States, or 19% of the United States electrical energy comes from nuclear fission power plants. Now, nuclear fission is a process in which you take a large atom and you split it into two or more smaller atoms through the use of hitting it with a neutron. For nuclear fission reactions, there we go. Uranium-235 is the most common form of, is the most common element used, and it is split into barium and krypton as the baby products, and it puts off a lot of energy in the form of heat. Now, the barium and krypton are isotopes, which means that they are unstable and not in their natural form. Now, to get in their natural form, they do something that is called decaying, which is a form of radiation. There are three different kinds of decay that occur: alpha, beta, and gamma. Alpha is at the top, beta is in the middle, and gamma is at the bottom. Those are the Greek letters for it. Alpha is the largest and slowest moving out of all of these forms of decay. It can be stopped by a piece of paper, your skin, or your clothing, but if it is ingested, it is very dangerous. Beta particles, however, are much faster moving and smaller and have to be stopped by something a little bit thicker. Most times it's aluminum. Now, gamma is the most dangerous, and it can penetrate almost everything, and it has to be stopped by a thick layer of lead due to its high energy and very, very, very tiny mass. Now, these occur in the fuel rods, which are radioactive once the fission process is complete. I will call these spent fuel rods. And these spent fuel rods are stored on site of the power plants. Most of the time, 90% of them, I believe it is, are stored, or according to the NRC, the National Regulatory Commission of the United States, I think. 90% of the fuel rods, spent fuel rods, are stored in giant pools of water, as seen here, in buildings made of thick concrete and lead. Now, this is not getting rid of the spent fuel rods, this is merely just putting them in water. So that doesn't really solve any issue. Another problem with nuclear fission reactors is the possibility of a meltdown. Meltdown occurs when the fission reaction starts to happen at an accelerated rate that we cannot control, and it gets out of control. The process creates massive amounts of heat, and it literally melts the barrier between the reactor, or the reaction, and the reactor. And here is a picture of Fukushima after the initial meltdown started to occur. You can see that places are on fire, and they're just trying to do anything they can to cool down the reaction. Now, this is a problem because it exposes the world to radiation, and this is a graph from Geomar of the level of radiation 133 days after the nuclear meltdown at Japan. The yellow in the middle is the level, or yellow right there, anything yellow, is roughly the same level of radiation as in the actual power plant. And that's not good. Now, I'm a nuclear engineer, so I'm not trying to say that nuclear energy is terrible and we should get rid of it completely, but I do believe that there is a solution out there, and I look forward to talking about it in the future with you all.